Hi everyone, in today's lesson we're going to talk about how to factor higher order trinomials. A higher order trinomial, or polynomial, same thing, is a trinomial that has a degree which is greater than 2. Now remember, degree is the highest power, so we have a 4, a 9, a 4, and an 8. So we're going to write down here that it has to have a degree that's greater than 2. So we're going to set up, let's start with example number 1, the same way we've done all trinomials, through guess and test. Now I'm actually going to give some space, and what should go in the front spot of the parentheses to multiply to a to the 4th? You should be telling me a squared. Okay, now I want the factors of this 24 that'll add to that positive 2. So I'm just going to write down the factors of 24, disregarding the negatives for a minute. 2 and 12, 3 and 8, and 4 and 6. Now I know 4 and 6 are going to differ by 2, so I'm going to try to play around with that. So 6 and 4. Now my outers and inners, I'm going to put them on top, and you'll see why in a minute. This is 6a squared and this is 4a squared. How am I going to get that to add to a 2a squared? The 6 will have to be positive and the 4 will have to be negative. Now what do you notice about this parenthesis in here? You should be saying this is dots. So I can actually factor this a little bit more. And that's why I put the outer and inners work on top, because I know I can factor this a little bit more. Just makes it clearer. Or you could erase it. Okay, that's it for the first one. Why don't you try example number 2 and then hit resume when you're done to see if you get the correct answer. Just a word of advice, you may have to take out a GCF first. Okay, here's your answer. Okay, so I took out a GCF of 2b first, and this is what I was left with on the inside. Now this is a trinomial, and the leading coefficient is 1, so I just simply did add multiply. What numbers multiply to negative 28? That add to negative 3, and I got negative 7 and 4, and that worked out perfectly. Now this in here is not dots. You can't factor this anymore. It's not a difference. It's a sum of two perfect squares. So you're done. That's your final answer. Okay, let's move on to example number 3. First things first, let's check for a GCF. I don't see one. I'm going to leave some space again because we may have to factor some pieces again. So let's see, what do I need to put into the first spots of the parentheses to multiply to a 2x to the 4th? We actually need a 2x squared and an x squared. And now we want the factors of negative 12 to eventually add to negative 5 once we do the outers and the inners. So I'm just going to write down the factors of 12, 1 and 12, 2 and 6, and 3 and 4. Okay, so let's just guess. I'll put a 6 here and a 2 here, and let's see what happens. So my outers and my inners, this is 2x squared, and this is 12x squared. Is there any way that a 12x squared and a 2x squared will add to a negative 5x squared? And the answer is no. So that means the 2 and 6 is not my right pair. So let's erase that. And let's try a different pair. I erased it, but let's try 4 and 3. Okay, now let's check our outers and our inners. So 4x squared and 6x squared. That doesn't look right either. There's no way that these will ever add to a 5. Okay, so how about if I switch it and put the 3 here and the 4 here? So let's do our outers and our inners. So that would be 3x squared and 8x squared. Ooh, that may work. Which one has to be negative? Well, this will be a negative 8 and a positive 3. If you add those, that'll add to a negative 5. So the 8 came from multiplying these two, so I'm going to make this negative and this positive. Now some of you may be thinking, I see dots, and you're absolutely right. So this will be x plus 2, x minus 2, and a 2x squared plus 3 in front. And then this is your final answer. Okay, why don't you see if you could try example number 4. Pause the video, see if you can do it, and then hit resume when you're finished. Okay, here is your answer. Okay, if you stopped here, unfortunately it's not entirely correct because this is another dots. So what you really should have is x squared plus 1 and x squared minus 1, and then we can bring down this 5x to the 4th plus 3. Did anybody get anything different? Well, you should have seen that this is dots again, so that means my final answer is 5x to the 4th plus 3, x squared plus 1, and then x plus 1, x minus 1. All right, awesome. Let's see if we could try example number 5 and 6. Okay, example number 5 and 6 are also multivariable trinomials. So these are a little different, but again, it's all done the same way. So let's put our two sets of parentheses. And now what can we put in the front spots of the parentheses to multiply to x to the 4th? You should be telling me x squared and x squared. Now we need the factors of 7 that are going to add to negative 8. Well, I know the factors of 7 are either going to be 1 and 7 or negative 1 and negative 7. So I know that this pair is going to add to this, so I'm done. Now it'll have to be a negative 1 and a negative 7, but remember it has to multiply to y to the 4th, so I need a y squared in the back end of the parentheses. And the real reason why we don't have to do the outers and the inners is because this leading coefficient here is 1, so we could just go straight to AM. But let's just check it and see if it works anyway. And it looks like it does. Negative 7x squared y squared plus negative 1x squared y squared is negative 8x squared y squared. Okay, now unfortunately this isn't finished yet because I actually see here is a difference of two perfect squares. So this is x plus y, x minus y, and then x squared minus 7y squared. Finished. Okay, why don't you give number 6 a try? I'll give you a hint that you're definitely going to have to take out a GCF first. Okay, here is your answer. The first thing that I did was I took out a GCF of 2 and I was left with this trinomial. Then I decided that I had to factor this and I used the add multiply method, and I said to myself, okay, what numbers multiply to negative 80 that are going to add to negative 11? So I figured out it was negative 16 and 5. And then I knew that x to the 4th had to go in the front spots of the parentheses because it needs to multiply to x to the 8th. And I knew I had to add an x to the 4th at the back end of the parentheses because it needs to multiply to y to the 8th here. And then I just factored using dots a little bit more here. This is a difference of two perfect squares, and I broke it down into here. So this was this one. And then I realized that this is another dot, so I broke that down into this piece, and I brought everything else down. Alright, so when you come in tomorrow, we're going to discuss all different types of trinomials, and we're going to review how to factor them all. Alright, have a great night.